Okay, we've attached our plate made of tape and cotton swabs, and now we'll run another test on the closure. It shouldn't change it too much, but just to get data for our experiment, we'll take it out 1.5 meters again. Okay, there's 1.5 meters. We'll let that settle out. little bit. It's taking on a life of its own here in space, but you can see that as it gets oscillating, just like any other object in space, once it's in motion, it's going to stay in motion for quite a little while. So. What's that? Okay. I'm not catching this one. Okay. Okay, so be ready on that timer again. I'll give you a 3 count with a mark. 3, 2, 1, mark. Huh? Okay. So there's that'll give you a little, with the mass on the end of this, how quickly it'll travel to impact our orbiting object. Can you hit pause and then what were you saying? I'm sorry. Okay, the next part of the experiment is, of course, to get our orbiting object, and just like Hannah had proposed, we took an eraser. We didn't have a square eraser, so I had a rectangular eraser, but I cut it and then fashioned it together so it would form a cube, just like Hannah had done in her experiment on the ground. And instead of string, we're using dental floss, and we've tied that around the eraser, and we've measured out 40 centimeters, just as called out in the experiment, and we've tied a slip knot and to a Sharpie fine point pen, and that'll be our center of rotation. And we're going to measure. I'll hold the pen up here 40 centimeters above the eraser, and the eraser is going to stick out about 1/3 of the eraser, and then our plate made of tape and cotton swabs will impact the eraser and send it with an initial velocity orbiting the central point, the Sharpie pen. Now in the experiment, Hannah calls for setting this down. Of course, she was working with gravity and working for her, and so in order to set this flat on the tape measure, of course it wants to depart. So we're going to have to keep it down there, rather than me holding it with my hand, I'm going to use just a small piece of tape just to keep it in position, but that will allow the eraser to be knocked off when it's time to rotate. Okay, we're back, and you can see now that we don't have gravity working in our favor here, but the eraser appears to be lying on top of the tape measure, with about 1/3 of it sticking out to be impacted by our object to send it orbiting. I used just a small piece of gray tape to just hold it in position. It should be just small enough where it'll allow the eraser to be knocked free at the start velocity. Then we have our 40 centimeters. You can see our 40 centimeters of string, and in this case we're going to use dental floss, and I'll use my hand, keep my hand steady, holding the pen or the central point of rotation, in place, and then we'll measure the speed of each orbit. And so if you have a hard time seeing it on the camera, I'll just count number 1, 2, 3, and we'll let it go for maybe 5 orbits, and we'll see how the time of each of those orbits slows down. I hypothesize that it will, due to the drag in the air here, that we'll see affect the speed at which it orbits the object. So, are we ready? Get ready on the timers, and we'll pull it tight without pulling the eraser off. And Tracy's ready on her timer. And here we go. Each revolution will time. Okay, here we go. 3, 2, 1, mark. Oh, crap. Okay, cut. Okay, we're back, and the first rotation, actually, we impacted the handrail up here a little bit, so I'm gonna move it down just a little bit to give us a little extra room for the complete rotation. Okay, we've got our tape measure sent out 1.5 meters, and we've got our impact mass there, and we're ready to go again. So if you're ready on your timers, and I'll be counting the number of revolutions